Consider the function z equals f of xy equals x squared y. Now this isn't exactly the situation that we did in class. I actually made kind of a bad choice with the value of t. Anyhow, x of t equals cosine t, just as it did in class. Y is the natural log, in this case, of 1 plus 4t over pi. Okay, now I chose the 4t over pi instead of the t over pi that we did in class and is in the document, simply because then we're still going to get a natural log of 2 when we let t be pi over 4. Okay, so, well, what I want to know is what happens if t changes from pi over 4 to pi over 4 plus 0.02. Okay, first place, let's figure out what happens when t is pi over 4. Okay, well, when t is pi over 4, cosine of t is cosine of pi over 4, which is the square root of 2 over 2. And of course, that's x of pi over 4. Y of t is going to be the natural log of 1 plus 4 times quantity pi over 4 divided by pi. And 4 times pi over 4 is just pi. Pi over pi is 1, so this is 1 plus 1, or 2. Natural log of 2 is approximately 0.69. Follows then that when t equals pi over 4, z is f of what? Well, it's f of square root of 2 over 2, because cosine of pi over 4 is the value of x when t equals pi over 4. And 0.69. I guess I've got room to write that, okay? Now if you evaluate that, square root of 2 over 2 squared gives you 1/2. Y is just 0.69. 1/2 of 0.69 is about 0.35. Okay, so when t equals pi over 4, z is about 0.35. Okay. Now we want to ask what happens, again, if t changes from the pi over 4 value by 0.02. We add 0.02 to the value of t. Well, we could consider the graph of x versus t, and x being the cosine function has a graph that looks something like this, and then of course it continues on. And pi over 4, this would be 0 to pi over 2. Pi over 4 is halfway here. So we have a value when t equals pi over 4, x equals the square root of 2 over 2. Now if t changes by a little bit, and a change of 0.02 is kind of small to indicate on here, so I'm going to kind of exaggerate the change, and maybe I'm going to use a different color. I have a lot of trouble keeping up with good pieces of colored chalk. Anyhow, so let's say here is a displacement of 0.02 from the pi over 4 value. Okay, so this would be pi over 4 plus 0.02, and an arrow. I'm not going to draw the projection lines, but an arrow from this point to this point would be about this long, and this would indicate or represent 0.02. We could, of course, evaluate the cosine function at pi over 4 plus 0.02, and we actually want to do that. But really, I want to use differential approximations or tangent line approximations. So this tangent line here has a slope of what? It's going to be negative sine of pi over 4, because of course the derivative of the cosine is negative the sine. So my slope here is negative sine of pi over 4, which is negative square root of 2 over 2. And that's approximately negative 1.4 well, 1.414 divided by 2, and that's going to then be 0.707 approximately. We can use this 0.707 slope. That slope isn't going to change much if t changes by 0.02, so that we're going to have a y value at the pi over 4 plus 0.02 point that differs from the square root of 2 over 2 that we got for the cosine of pi over 4 by what? The difference is approximately negative 0.707 times 0.02, which is going to be negative 0.01414 if you like. Okay, so there's the approximate difference in the value of x. So that a change in 0.02 of t, a change in t of 0.02 at the point where t equals pi over 4 is going to result in a change in the value of of x, change of about negative 0.014. Okay, well, we can then say that change in x is approximately equal to what? It's x prime of t times, I was going to write delta x, times delta t. Okay? Now, what change does that imply in the value of z, assuming that y remains unchanged? Okay, well, we're going to draw a picture of this, and we'll go on to get this in a subsequent video, but I'll also, before I wrap this one up, say we can do the same thing for y. Okay? So, if we sketch a graph, and I'm going to sketch it here, of y versus t, we have the graph of the natural log of 4t over pi. And it's shifted over a little bit. It's shifted over by by some small distance, so that it's going to be shifted to the left a little bit. And I probably should have worked that out previously, but it's going to have a graph that looks something like this. Okay. Then at pi over 4, t equals pi over 4, we get a value of y that's approximately equal, again, to 0.69. It's approximate. There are a few more significant figures. There's a fly in here. Okay. And what happens if we change this by 0.02? Okay, so let's say we do the same thing. Now we change the value to pi over 4 plus 0.02. Well, what's the slope at this point? Okay, I'm going to suggest before we do the next video that you imitate what I did up here. What's the derivative of this function? And then what do you get if you plug in pi over 4 to the derivative, because that's going to give you the slope. Remember that the derivative of the natural log of t would be 1 over t. But of course we have a chain rule involved because we don't have just plain old t here. So we have to talk about the derivative of what's inside the parentheses.